let's look at this example here. The derivative of the secant of x, that's the derivative of 1 over the cosine of x. So let's do this from the low d high perspective. Low is cosine of x, high is 1. So low d high, cosine of x times the derivative of 1, which is 0, by the way, minus 1 times the derivative of the cosine of x. Guys, this 1 is just understood right here, where my cursor is now, okay? Now, this term zeroes out. Now, guys, the derivative of the cosine is the negative sign, but we have another negative here, so we have the negative sign, which is just the sine. So we have the sine of x over low squared, which is the cosine squared of x. So we have that. So now this is correct, but there's a prettier way to write this. Note that the sine over cosine squared can be thought of as, well, that was redundant. I wrote the same thing twice there, so let me get rid of that. And that can be thought of as the sine over cosine times 1 over cosine. And then, but now the reason why I wanted to treat it like this is because sine over cosine is the tan, and 1 over cosine is the secant. So this is more commonly called the secant x times tan x, the secant tan. This is just a real common way to write the derivative of the secant of x. You'll see sec tan a lot more than you'll see sine over cosine squared, okay? May as well just get used to that. And I'll leave it for this guy right here for you to do right here, okay? And here's a low d high. So, but really, we're going to do this one a little differently. We're just going to use the chain rule. So we have d by dx of 1 over x plus 3. That's the derivative of entity, x plus 3 to the negative 1 power. Now remember, by the chain rule, you turn x plus 3 into u. So du would just be dx, so to speak. So I do d by du of u invert, and then times d by dx of the x plus 3. This is by the chain rule. If you're rusty here, go back and review the chain rule. So by the chain rule, we derivate u to the negative 1 with respect to u, and then we multiply that by the derivative with respect to x of x plus 3. These are both easy derivatives. The x derivative is really easy. The u derivative is pretty easy too. Hey guys, this x derivative is just 1, because remember this plus the sum of the derivative is the derivative of the sums, so the derivative of x with respect to x is just 1, and the derivative of 3 is 0, so it's gone. So this is just a positive 1, but if we multiply anything by 1, we just get the original thing, so we can just look at this guy right here where my cursor is, the derivative of u, the derivative of u to the negative 1 power with respect to u itself. But remember, by the exponent rule, the negative 1 comes down in front, so this is an understood negative 1 here. And we subtract, and remember, by the power rule, I say exponent rule, I should say power rule. By the power rule, we subtract 1 off neg 1, we fall down to neg 2. So that's negative 1 times u to the negative 2. That's just negative 1 over u squared, okay? But remember, we're on our bound to go back to x. We need to come back around to x. So u is x plus 3, so that's negative 1 over parentheses x plus 3 squared, and we do need the parentheses here. We're again reminding you that u equals x plus 3, or actually this is where I stated it, or I've already verbally stated it, but anyway, there's that. And the derivative of the sine of x minus 4, remember we do the chain rule. And my computer's a little funny, don't worry about it. We should still be fine for the video. We do d by du of the sine of u by the chain rule. That's the outer part. The sine is the outer part. And then the inner part's the x minus 4, so we derivate with respect to x, the x minus 4, we get, which is just 1 on that part. The derivative of u with respect to, the derivative of sine u with respect to u, that's just the cosine of u. And so there's that. And sorry about that. This thing skips down to the next page. I'll try to fix it if it won't act up on me. There we go. But remember, u is x minus 4. That's how we define u. So we got to plug x minus 4 back into here. Cosine of u is the cosine of x minus 4 because u is x minus 4. So there's that. That's the chain rule. Remember, you turn the inner part, you replace the inner part with u, and that lets you derivate the outer part with respect to u. and then you got to go back and derivate that inner part with respect to x. That's what's going on here. That's the so-called chain rule of calculus. Okay. Let's look at another one. D by dx of 1 over radical x plus 3. We could do Lodi high on. We could have done Lodi high on a few of these. Well, not the sine ones or the trig ones, but on the others, the rational ones, and even on this one we could. But let's do this using the chain rule. So the derivative of 1 over radical x plus 3, remember square root of x plus 3 is x plus 3 to the half, but because it's on the bottom, it's to the negative half power. So we're derivating x plus 3 to the negative half power with respect to x. But remember, substitute u in for x plus 3. We're going to go ahead and do this part right here. So we're replacing x plus 3 with u, so we got u to the negative half power. Now by the chain rule, we derivate u to the negative half power with respect to u, and then we derivate x plus 3 with respect to x. Now again, boringly, the derivative with respect to x of x plus 3 is just 1, and 1's not really going to do anything because we're multiplying by 1. Now d by du of u to the negative 1/2, remember the negative 1/2 jumps down in front. We subtract 1 off the negative 1/2 that was up here, and we get negative 3/2. Okay, this is when you go in and you execute the derivative. Remember the negative half comes down, and the negative half up here turns into negative 3/2 because you subtract 1 off of it. Negative half minus 1 is negative 3/2. So upon execution of the derivative. So there's that. Now guys, remember u to the this negative sign just sticks. Okay, it just stays out to the side. This negative sign indicates that u to the 3/2 needs to come down here. So we're going to turn this negative 3/2 into positive, and the price we have to pay for doing that is we have to bring that u to the 3/2 down here. Remember, a negative exponent means reciprocal. Okay, so that u to the 3/2 comes down here with this 2 right here. And so we have, but now guys, we're honor bound to replace u with x plus 3. We got to put x plus 3 back in place of u. So we do that. So we have negative 1 over 2 times entity x plus 3 to the 3/2 power right here. Okay, so, but now remember, what is the 3/2 power? Like x to the 3/2 power would be x times the square root of x. So x plus 3 to the 3/2 power would be x plus 3 times the square root of x plus 3. Now, guys, some of your calculus teachers, they would be happy for you to stop here. But if they want you to write everything in radical form, and even more particularly, if they want you to rationalize that denominator, gulp, gulp, then you'll have to go do this step right here, put it in radical form. But to rationalize that denominator, you need to stick another radical x plus 3 down here. And because you stuck this second guy down here, you got to stick that same term up here. But now remember, by associativity, you can go ahead and multiply these two radicals, and you'll get x plus 3 itself. So we get x plus 3 here that was already here times this new x plus 3 that came about on account of the two radicals. Remember, radical x plus 3 times radical x plus 3 is just ordinary x plus 3. So we get negative radical x plus 3 over 2 times x plus 3 times another x plus 3. But hey, now you guys, you see that negative and that 2, we can take those out as negative half. We have this radical x plus 3 upstairs. Hey, x plus 3 times x plus 3 is just quantity, parentheses, x plus 3 squared, okay? So there's that. And that was painful, but I wanted to show all the steps. Sometimes your teacher may be satisfied here. Sometimes they may not care if you rationalize the denominator or not. That depends on your professor. That's a question I really can't answer, because your professor's taste is something that would be hard to know. Let's go look at this next problem. Now this is just plain radical x plus 3, the derivative with respect to x of square root of x plus 3. Now guys, remember that's x plus 3 to the positive half this time. That actually makes life a little bit easier. Remember, we execute the derivative. You know what? We don't really have to have the chain rule. I go ahead and I really should use a chain rule here, to be honest, and do it like I did up here, but I kind of got away without even really using the chain rule. So let's just see if I can get away. I just bring the 1/2 down and do x plus 3 to the negative half. That's actually a little sloppy and cavalier, but I can get away with it. In general, I cannot get away with this, okay? But for this problem, I can. I wish I would have been a little less cavalier, but oh well. Let's do this right. I don't want to set you up for bad habits. I don't want this to come back bad on me later. I should have saved. What I did is correct, but it's too soon. That's what it boils down to. Oops. It's correct, but it's too soon. So let's do the chain rule. Let's replace x plus 3 with u. So I'm gonna raise u to the power of 1/2. Okay. I don't want stuff to come back and bite me later because I got sloppy. That's what I'm afraid of. And besides, your professor would probably frown on what I just did without justifying my stuff. So yeah, justification is good. And then what's going on, guys, is we're replacing x plus 3 with u, and we're doing u to the 1/2 power. And by the chain rule, that's d by du of u to the 1/2 times d by dx of x plus 3. But hey, I need to insert this next step. Excuse me. If I do d by du of u to the 1/2, that's 1/2 u to the power of negative 1/2. And then if I do d by dx of x plus 3, I'm not going to write that. That's just 1. It's not going. I multiply by 1. That doesn't make any difference. So I just have this guy right here, 1/2 u to the negative 1/2, because this guy didn't make any difference. Now, I'm not, guys, disclaimer, there are situations where this guy will make a difference, but just not if it's a line of slope positive 1, okay? We'll generalize later, but enjoy the solved situation while we've got it. Enjoy this pretty scenario. You do need to write this. This is not a waste of time right here, okay? Lest there be any mistake. You've got to write this, because in general, this won't, equal 1. You don't get too used to that, okay? That's going to change later. But anyway, we have 1/2 u to the negative 1/2, and so it's going to be, we got to replace u with x plus 3, go back where it came from. So it's 1/2 parentheses x plus 3 to the negative 1/2. That's going to be 1/2 radical x plus 3, because that negative 1/2 power means a radical on the bottom. But remember, we stick a radical x plus 3 down here, and we got to stick one up here, because we want 2 of those guys on the bottom, because I know in my heart of hearts that radical x plus 3 times radical x plus 3 will just give me plain Jane x plus 3. Now that 2 is going to distributively multiply x plus 3. You'll wind up with, well, if you distributed this, yeah, sure, it's true, you'd get 2x plus 6 down here, but I don't really want to dwell on that. That is true. You would have, if you hate parentheses, you can drop them and write 2x plus 6 distributive down here. But anyway, and then we have radical x plus 3 up here. But I'm going to, what I prefer to do is just, instead of distributing, I'm going to go the other way. I'm going to yank that 1/2 out and just write this as 1/2 times radical x plus 3 over ordinary x plus 3. I just like that form better. I'm sure if you wrote this as radical x plus 3 over 2x plus 6 with no parentheses here, your professor would take it, I'm sure. More than likely, but let me just do this my way, okay? And again, we replaced x plus 3 with u. That's what all this was based off of. And you do these two, and do them, just do them this way. Do them the way I just did them, okay? And use your substitution. Notice I use the letter U. You don't have to use the letter U. You could use P or something like that. Just be careful, okay? But there's that. I think U is kind of the standard, but strictly speaking, it's just a letter that I like to use. I think that's what we used when I took calculus, and I just kind of parakeeting that. But anyway, let's do some more chain rule. The derivative with respect to x of 5 minus x to the 100 power. We do not want to do algebra and expand that out. That would not be fun, right? Let's do the chain rule. Okay, let u equal 5 minus x. So replace 5 minus x with u. So we have d by du of u to the 100 power. So that's, and then times d by dx of the interior, which is 5 minus x. Aha, notice this time we can't completely ignore this guy. He's -1, he's not +1. So we have, if I do this derivative, d by du of u to the 100, that's 100 u to the 99 by the power rule. But and this guy's -1. Aha, we can't completely ignore him. And in general, we can't ignore him at all. We should never ignore him anyway. Now, by the rules of algebra, multiplication by -1 just puts a negative right here. If that would have been like a -2, this would be -200 instead of -100. That didn't occur in this particular problem, though, but anyway. So there's negative 100 u to the 99. And then, but you got to replace u with the parenthetical. Remember, we want things in terms of x. So it's negative 100 parenthesis 5 minus x to the 99 because u is 5 minus x. And we do need these parentheses here because we're raising the whole thing to the 99th power, okay? So there's that. And now if I stuck a negative in front of this 5, it doesn't really change the main idea much. You just go through the same procedure. This negative 5, guys, is going to get killed. I should have emphasized this up here. This positive 5 got killed up here. It just died to 0. It was the negative x that gave you the negative 1. And in a similar fashion, this negative 5 gets killed, and the negative x gives you negative 1, just like it did before. You'll go through the same motions, except you'll end up with a negative 5 minus x in here instead of just plain positive 5 minus x. But the idea is largely the same, okay? And u is going to be negative 5 minus x instead of just positive 5 minus x, naturally, right? So there's that. And I'll leave it for you to do this problem here and this problem here on your own, okay?